Assalamu alaikum everyone, this is Said Said, market number 204716, and I'm going to show you how we do the final motor housing design. So as you can see, this is the final motor housing design. Overall is a simple design whereby a motor will be housed inside and the torque of the motor will be transferred to the propeller through the shaft. So first of all, we started with the housing compartment, and the way we did the housing compartment is because we want an empty hollow inside. So the thickness of the C-section is 2 mm, and the height of the housing is 30 mm. So after we finalize the sketch, the reason why we did this C-section is because we want to execute the shaft. The shaft option, in the shaft option, allow us to indicate any cross section about design of the axis. So how we designed our different axis is x-axis, and the rotating is 135 degree in one side and 135 degrees on the other side, with a total of 270 degrees. So there's option of increasing and decreasing the angle if we want. So as seen up, we can change to 150 degrees, or we can reduce it to 90, and it will give you that view. So for our final design, we just choose 35 for each side. Now we have created our C-section housing part. So after that, for sketch number 2, we did the base of the motor housing with a total length of 40 mm and height of 25 mm. After we did the sketch, and as usual, we went to set the thickness of 2 mm, and this is where it's going to be attached to the arm. So the total thickness of the motor housing and the base of the base and the C-section will be 32. So after we satisfied with that, we can go again. So the next part, we are going to hide the different sketch. We have created now another plane on top of the cylinder. So the reason why we did that is because we want to design the shaft where the propeller will be attached to. So from this cylinder, we've created this plane and offset of 28 mm from the reference, as it can be seen, attached to the cylinder. After that, we are going to sketch on the plane. As you can see, we drew a circular shaft of diameter 5 mm. After we did this sketch, then as you can see, this is the shaft with the length of 20 mm, and this is the shaft. Okay, after we did the shaft, we have to account for the cooling of the motor. For cooling purposes of the motor, we did this sketch here. This is basically a lantern eclipse. As you can see, this is the sketch. We get 5 mm for each of the cylinder, the top and the lower. So the distance from the center will be 5 mm to the top of the motor housing. After satisfied with the sketch of the cooling window, now we can use just the pocket command, and the type of the pocket we want is up to next. Is because we want to penetrate the cylinder, and we are going to choose up to next. So here we can have smooth airflow in which it will cool the motor. So for the outlet, we fill the circular pattern, and we want 5 instances of this window, and the angular spacing is 45, and the total is 180 because 40. Yes, so the total is 180, and the reference axis for this is the z-axis. So therefore we can see this is the design in which when the motor is doing work, it can be cooled, because the motor creates heat when it functions. So if we don't cool it, the drone cannot function properly without the cooling. And finally, for our design, we did the edge fillet, so this way it will be more efficient. So we selected 4 elements, and the radius is 5 mm. So the edge is 1, 2, 3, 4, and the final one is that one, and the radius is 5 mm. If we want, we can say 7, and we can see how it look, but we wanted 5. And the reason behind this, we are gonna create additional 2 holes, so we don't want them to be so closed. So 5 mm is sufficient for our design. If we choose the radius and the location of the hole change, it may have area. So this is a simple design, and as hole, we know it's easy to make. We just created the hole and the dimension of the hole. So as we know, the diameter of our hole is 5 mm. So you can choose up to next, or you can set the depth if you want. Anything like that is possible. So we chose the center of the hole to be 5 mm from the next edge, and 12.5 from the lower edge. That way the location of the hole. So if we exit and preview, we can see where the hole is located, and if we like what we see, then we move to another part. So finally is the rectangle repetition pattern. So we don't have to make the hole again, we just made one hole, and we go to the rectangular pattern definition. It's over here in the toolbar. So rectangular pattern allow us to repeat any kind of element at any spacing we want. So we want this hole, So we select the object hole 1 and we want to instance, and on the second instance we want to be the distance to be 30 mm, and the reference is the x-axis as we can see here. So this hole in the second instance is moving the x-axis, so we can choose the hole spacing to be 40, but as you can see it will be out of the edge, so due to our dimension the spacing will be 30 mm is okay. And we can see here different views of our motor housing. Everything is fine, the holes are located at the same place, and this is how we design the motor housing. So thank everyone for watching, and thank you.